Okay, so where we left in our last video, so by assuming A, the area of the circle greater than the area of the triangle T, we saw that the area of the triangle came out to be less than the area of the polygon. And the area of the polygon is nothing but n times the area of each of these triangle OAB, because there are n triangles within the polygon, which becomes equal to half HQ, Q being the perimeter of the polygon, which of course has to be less than half RC. And what is half RC? It's nothing but the area of the triangle. So here we got T less than P, but P is less than, that is, but from here we see that P is less than half RC, and that means less than T, right? So here we see a contradiction, right? So we can see that this is a contradiction. Okay, so therefore his assumption has to be wrong. So therefore A cannot be greater than T. So he was relieved by seeing that at least one way he could be wrong is eliminated. So A cannot be greater than T. So what's the next possibility? The next possibility was case 2, where the area of the circle A is less than the area of the triangle T. So for this he drew say a circle. Now this is the inscribed circle now, and he drew a circumscribing regular polygon of sides n. Now here again I am not gonna draw the whole polygon because it's of a very large number of sides. So let me remain like this. Okay, so here he then said, suppose this is the center, and he drew the radius, and this is the similar triangle. Okay, so this is the side of the polygon with B, and the height of the triangle, this is again OAB, the height is H. Okay, and this is 90 degree, right? So he said that with large n, so for large number of sides of the circumscribing polygon, he can make the difference between the area of the polygon minus the area of the circle can be made as small as possible. So of course can be made smaller than this T minus A, where T he assumed now to be greater than A. So again he wanted 0 on the right hand side, so he did the same trick, P minus A minus T plus A, and here T minus A minus T plus A, so the right hand side is 0 and this cancels, therefore P minus T is less than 0, therefore P is less than T. So by assuming that the area of the circle is lesser than the area of the triangle T, he came up with the area of the polygon being lesser than the area of the triangle T. Now again let's find what's the area of the polygon P. The area of the polygon P is nothing again but n times the area of this triangle OAB, because there are n triangles that constitutes this n-sided polygon, right? So this is n times area of triangle OAB is half HB. Okay, and again what is n times B? It's nothing but the perimeter of the polygon. So this is half HQ, where Q is the perimeter of the polygon. And here you see that H is equal to the radius of the circle, but Q is the perimeter of the circumscribing polygon, right? So it has to be greater than half RC, because H is same as C. Excuse me, H, the height of the triangle H is same as R, the radius of the circle, but Q being the perimeter of the circumscribing polygon has to be greater than the perimeter of the circle C. And what is half RC? Again, which is nothing but the triangle T. So we see that P is greater than half RC, so greater than T. So again, you see we get contradiction. By assuming the area of the circle less than T, we come up with the area of the polygon less than T. But we see from our figure, from logic, that area of the polygon has to be greater than T. So it is a contradiction. Therefore, his assumption A less than T cannot be true. And he was relieved that the two ways he could be wrong are eliminated. So therefore, he said it has to be true that A is equal to T. And what was T? T was the triangle with base equal to C and height equal to R, where C is the circumference of the circle, R is the radius of the circle, which is equal to half 2 pi R times R equal to pi R square. So proved. And I would like to acknowledge the book Journey Through Genius by William Dunham for the material I covered today. And I hope this was very interesting for all of you. Like, you are very excited to learn about it, just like how I was so interested and so excited when I was learning this. So that would be all for today. Thank you.